This first one, let's see that. This should equal 2/3. I'll put it over here. Down here. Which should be negative 2/3. And again, it doesn't matter if you have negative and then 2/3, or if you have negative 2/3, or if you have positive 2 or negative 3. As long as there's one negative, the whole thing's negative. That one over there is. So that's going to be positive 3/2. So that is going to be that's going to be 2/3. I mean 2/3. So on the first slide. Number 2. 2, then 5. Number 2. 8 minus 24. So positive 8, take away 24. There's more negative than positive. So the numerator is going to be a negative. So if I win $8 of a check chance, then I lose $24. How much have I lost? I have $16 in the hole. I'm down $16. And then $36, I win 36, but then I lose 12. So now how much am I ahead? 24. So the numerator is negative, the denominator is positive. So my answer is going to be a negative. Always assess the sign. Is it positive or negative? Now you focus on the 16/24. Now we've got to reduce it to lowest terms. So you need the greatest common factor to simplify it. And if you can't think of the biggest number, then whittle it down. They're both even. So if you're just going to whittle it down, you can whittle it down and say, all right, this is going to be a 2 times an 8, and this is a 2 times a 12. So now you have basically negative 8/12, but then make sure you realize I can still whittle it down. This is equal to a negative, that's a 2 times a 4 over a 2 times a 6. So I can reduce the 2's again. But 4/6 is still a positive over positive. So that's a 2 times a 2 over a 2 times a 3. 2/3 can't reduce, so I have a negative and then the 2/3. But what was the biggest number that I could have just done? 8. For a 16 and a 24, the biggest number that goes into both is 8. So we could have just said this is negative 8 times 2 over 8 times 3. 8/8 reduces, and I'm left with negative 2/3. A lot of times people struggle with reducing fractions because you're trying to do it in your head. Show the factory. Show how that breaks down. What times what is 16? Write it down and try to figure out something that is the same factoring as the 24. Don't choose things that don't work. Don't choose, all right, for 16, I want to go 4 times 4 And then for 24, I'm going to go 8 times 3. Because I don't see anything I can reduce. At least not off the bat. I want to pick something that I can start with and just make it smaller. And then do it again. Okay? You know, it's small bites. Take it apart with small bites. When you go to one of those, you know, all-you-can-eat buffets, and you fill up that tray, you can't eat it in one bite. Hopefully you pick at it for a while. It's a waste of money for me because, yeah, I'm fat, but I can't eat a ton. I just feel bloated, and it's not worth it. Now my buddy who is bottomless pit, he can eat for days and days and days and days and not gain a pound. It's like, where's the equity in that? Well, there isn't. Okay, just that's how his metabolism is, and that's how my metabolism. But the thing is, he can eat it all in one bite. He chews with his mouth open, but hey, one thing or another. Small bites, take it apart. Number 5, you lose $8 and you lose $24 more. So how much have you lost? $32. It's a negative. This is a negative 32 over. You lose $12, then you lose $36. So how much have we lost? That's a negative 48. So those negatives are losses. So you keep the sign and combine how many negatives you have. It's not multiplication. I will, at many levels I'll get, hey, I thought a negative and a negative made a positive. If we're multiplying or dividing, if I multiply 2 negatives together, I get a positive. I'm not multiplying, I'm just adding and subtracting. So we're combining them together. I have 12 negatives, 36 negatives, that's a total of 48 negatives. So a negative divided by a negative, I now know my answer is going to be a positive. I don't have to worry about the signs anymore. Taking care of the sign first. Well, yes, because if the signs are the same, if I multiply positive, positive, I get a positive. Negative, negative, I get a positive. If the signs are different, then it's a negative. Same with division. Positive over positive, positive. Negative over negative, positive. Positive over negative or negative over positive. If they're different, it's a negative. For multiplying and dividing. What's the biggest number that goes to 32 and 48? That's not the biggest. And that's okay. We can whittle it down with that, and I will do that in a second. But let's shoot for the biggest first. 16. 16. This is 2 times 16. And this is 3 times 16. So that's the answer, 2/3. That's that advantage of knowing your multiples. Because I do this every day. I'm used to seeing 48 as 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't go, 6 times 8. But there's all those ways you can make 48. And that's kind of what you have to do is how many ways can we make 48? How many ways can we make 32? What's the biggest number that works both ways? When we get into factoring polynomials, you're going to want to make a list. How many ways can you make a certain number? Because it's going to help you make better choices. If you don't write them down and you're just trying to doing it in your head, you can't keep track of what you've already tried. If you don't know that it's 16, I heard 8. So this would be 32 is 4 times an 8. 48 is 6 times an 8. So the 8's reduced, but you have 4 over 6. And then I'll see people stop. And they leave 4 over 6 as the answer. That's not lowest terms. It's not simplified. You still have something a little bit more that you can do. See, here's why. The answer in lowest terms is 2/3. Well, equivalent to 2/3 is 32 over 48. It's exactly the same ratio. 4 over 6 is exactly the same ratio. Okay. 6 over 9, exactly the same ratio. 24 over 36, that's exactly the same ratio. 200 over 300 is exactly the same ratio. There's an infinite number of ways to write a fraction as 2/3. So imagine what us poor math teachers would have to do if we had to grade an infinite number of possible correct answers that all are equivalent to 2/3. That's why we demand lowest terms. Make it simple. The simplest version of all of those fractions is 2/3. Why? Because everybody should be able to break it down to its simplest form, where you don't have any common factors in it. All of these reduce and equal to. There's one final simplified answer. Okay? Any of these others, 1, 3, or 4. 3. So 36 minus 12 is 24. 24 minus 8, that's the 16. You see how the numerator is now bigger than the denominator? Over here, 16 over 24. The numerator is smaller. Over here, 32 over 48. The numerator is smaller. So when we reduced it, the numerator better still be smaller than the denominator. But it was reversed. What I did was I flipped it. Okay? It matters. 3 over 2 is different than 2 over 3. So now the biggest number that goes into both is still going to be 8. 3 times an 8 over 2 times an 8. 3 over 2. We're going to be working in section 1.2 with this formula for slope. You have 2 ordered pairs. Ordered pairs means you have a parentheses with a set of coordinates. You have an x coordinate and a y coordinate. And because there's 2 of them, we have to be able to distinguish between the first ordered pair and the second ordered pair. So the way we do that is a subscript. Superscript is up here, like an exponent. Superscript is above, a subscript is down below. This is x sub 1, that's the first x coordinate. This is y sub 1, that's the first y coordinate. So this would be the first point. The first set of coordinates, the first order pair, x sub 1, y sub 1. That's how it's pronounced. I know some people just say x1, y1. And that's okay. That's okay. It's the first x and the first y. It's just listing. You don't do anything with that one. It's not multiplied times one. You're not raising. It's just this is the first x to distinguish the fact that this is the second x and that's the second y. So there's an order to it. and they're different from each other. That's all. Then you get an X sub 3 and Y sub 3 and X sub 4 and Y sub 4. You can have a whole bunch of them. The slope of the line, and this is just a preview, is rise over run. And that just means it's the difference in the Y coordinates divided by the difference in the X. What operation is difference? Add, subtract, multiply, divide. We want to find the difference. What's the difference between $25 and $40? How would you figure out the difference between 25 to 40? You subtract $15 in between. So the difference between the Y coordinates and the X coordinates is the subtraction. Difference means distance. Distance, if I want to know how far it is from one point to the other, you take this distance to that distance and you subtract how far you went. But I wanted to know on the number line, how far is it from 3 to an 8? We take 8 and 3, we go 8 minus 3, it's a 5 in between. Now you could count, but what if this is 13/4 and this is 87/5? And I don't think we're going to make all those little notches and count. You just subtract the fractions. The difference is the distance in between. Difference is distance. So when we do slope, again, little preview, we take the difference of the y's. We go y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Why do we start with y sub 2? It doesn't matter which one you start with. It's just a label. Subtract the y's, subtract the x's. What matters is you don't pick this y and subtract that y, and then start over here and start with this x minus that x. They got to come from the same place. So if I start with this y, in the numerator, I got to start from the same order pair. I got to start from this x down here. Here's the point. Where you are minus where you were. That's how you find it. That's how you do your subtraction. Where you are minus where you were. I did the unit analysis about gas mileage way back when. Did I do that in here? Okay. I remember growing up, my dad used to keep, like a little tiny notebook in the glove compartment. In our Datsun 1200 from 1972. That I got to drive to school when I went to San Joaquin Memorial. The gear shift had a little, it rusted all the way through so I could see the road. As I was driving. Now, San Joaquin Memorial, I'm pulling in and there's a lot of BMWs and Mercedes and things like that. Broncos, and whatever. He would figure out the gas mileage every single time he filled up. Back then, there's no digital displays or anything like that. There's no press the button and it zeroes out the odometer. It's just one number, and that's your, how many miles you get in the pump. So when he would gas up, he would write down what the mileage is on the car. Next time he gasses up, he would write down the mileage, and then he would subtract to figure out how far he went, how many gallons he put in, because mileage is a ratio. Mileage is a fraction. Miles per gallon. That means miles per every 1 gallon. So you have to figure out how far you went, your distance, divided by how many gallons. My dad only finished 8th grade. I mean, he was born in 1917. Okay. I was born in 1967. He's 50. Yeah, he thought he was done. So I was a surprise. So the distance is the difference. So the odometer said at that car it was from 82,306 miles. And the next time he gassed up, it said 82,512 miles. Then he would take 82,512 minus 82,386. And you would do the subtraction. You got borrow, that's 0, that's a 12, so that's a 6. And then you got to borrow again, so that's a 4, and that's a 10, so that's a 2. And you go 126 miles. And maybe back then gas was like 73 cents a gallon. I used to be able to gas that thing up for $5. Because it was a real small tank too. Maybe he put 4 gallons in it. So he'd go, all right. Distance was 126, and let's say he put 4 gallons in it. So 4 goes into 126. Can't go in here, so go here. That's a 3, 12. We have a 6 left over in the 1, go 1, and then we get 4, and then we get 2, and then we put a 0 and a 0.5. 31.5 miles per gallon. I don't think it was that good, but that's, I'm trying to remember something from 1973, or actually 1970, before I drove, 79, 81, somewhere. But that's how they had to do it. Where we were when we gassed up, so where we were, where you are right now minus where you were will tell you how far you went. I applied to be an astronaut. Met a lot of teachers when I didn't make the cut. They kept 200 of us to be this group of teachers, the wannabe astronaut teachers. Okay, and I was in a group called NEAT, Network of Educator Astronaut Teachers, and we did a couple of conferences during the early 2000s. One was a week during the summer in Houston. The other one was another week in Florida at Johnson Space Center, or Kennedy Space Center. And then we did another one another one in Houston, like 2 more summers after that. And we got to meet a lot of astronauts and go on tours and bring back things to the class of developing time. I met one of the students one of the teachers that made it to the top 30. When you're in the top 30, you go through the whole interview process, like a 7-hour psych evaluation, a complete medical workup, a grueling interview process. Okay. And it was brutal. They only took 3 out of 1,600 hours. And they've all flown. 2 of them are still working. One of them is in charge of our return to the moon program. Okay. Former teachers. One day they're finishing up their school year. They get a call from NASA. You made it. We're going to fly you out to Pensacola, Florida for your survival training in 2 weeks. Say goodbye to everybody. And they're still with it. But anyway, this teacher that I met, she lived in Florida. She has family at the coast, East Coast. She gets a ticket in the mail. Speeding ticket. Never was pulled over. He got caught with slow. She paid over there on the East Coast, lot toll roads. If you want to be special, you take a toll road where there's less traffic. You get to you know. She paid her tolls with a credit card. So they knew exactly where she was and when she was. Miles per hour. That's speed. Miles per hour. So they knew where she was and when she was. So they had time and they had place. Then the next toll, the next time she came to a toll, they knew where she was and when she was. So they knew her second place, her second position. They knew her first position, so they could figure out the distance. They knew the second time, what time it was. They knew when she was at the first time. So they knew exactly how long it took her to get there. So they knew exactly how far she drove and how long it took her to get there. So if she went 100 miles in 40 minutes, or let's make it really simple. If she went 60 miles, in 30 minutes, 30 minutes is a half an hour. How many times does one half go on a 60? Right, this way. What is 60 divided by 1/2? What do you do with division? You multiply by the reciprocal. So this is 60 times 2. So how much is 60 divided by half? That's your average speed. So unless she found a wormhole somewhere between Florida and New York, at some point she was going well over the speed limit. So there's justification for getting her a ticket. When she decided that she wanted to go to the court and fight this, they asked her what she did. What do you do for a living? I'm a teacher. Well, what do you teach? I teach math. What kind of math? I teach calculus. And they asked her, have you ever heard of the mean value theorem, which is the proof for why she deserves a ticket? And she just, okay, you got me. How much do I know? Because there's no defense. It is impossible to go 60 miles in a half an hour without going at least 120 miles, either the whole way or going faster than that or sometimes slower than that. But it's all slow. Total distance, where you are minus where you were. That tells you how far you went. Divided by when you are minus when you left. That's your total time. All slopes are like that. How much per ounce? How many dollars per ounce? That's a slope. Miles per gallon, that's a slope. Dollars per ounce, or dollars per gallon, that's a slope. Everything in your life is based on slope. The whole idea of slope is the most important concept in mathematics because that's how we measure things. How much we pay per whatever. How much it costs per child to do this. What kind of a tax break per child do we get that? Okay. It's all about this piece of property I want to buy or this house I want to buy per square foot. How much do I pay per square foot? Paint. How many square feet on a wall is this paint going to cover? It's going to cover 3 square feet per gallon. Or actually, that's not much, but 200 square feet per gallon. It's a slope. It's a ratio between how much divided by how much. Two quantities. Okay? It's unavoidable. Number 6, and then we'll focus on the quiz. Questions you have. This concept of slope down. If you are, you're in this class in terms of the co-rec for Math 203, so you can do your Math 380 because you have this on STEM, science, technology, engineering, mathematics pathway. You're gonna need, again, slope is one of the biggest concepts that we cover in the rest of your math line. Slope. Okay. So 12, -2, x, +3, y, -4, and then 3 to the 4th, x, -5, y to the 7th. Okay. First thing I would probably do is take care of negative exponents. This flips down. So down below is 12 to the 2nd. X to the 3rd stays put. Y to the -4, that's going to flip down. So y to the +4 down here. So this one times this one. 3 to the +4 stays put. X to the -5 is going to flip down. It's now x to the +5. Y to the 7th, that's going to stay put. So in the numerator, 3 to the 4th is 81. I have an x to the 3rd, and I have a y to the 7th. I'm just organizing the numerator. I'm putting 3 to the 4th in front because that's the coefficient. 12 to the 2nd is 144. I have an x to the 5th times a y to the 4th. Now, is it wrong if I put y to the 4th and then x to the 5th? If I do that, is that wrong? No. No. However, why not use the alphabet to your advantage? If you put things in a nice order, you might see how things reduce a little bit better. If you organize what you're working with. If you organize this nicely alphabetically, you might see things reduce a little more clearly. X to the 5th, y to the 4th. But when I looked at what you sent me, you had these two in the wrong place. Okay. All right, so we have 81 over 144, so we're trying to reduce that. 9 times 9, 9 times 16. So I can reduce 9s. I have a 9 in the numerator, 16 in the denominator. X to the 3rd over x to the 5th. When you divide, you subtract the exponents. So x to the 3rd over x to the 5th, which exponent is bigger, the 3 or the 5? 5. So where is x going to end up? In the numerator or denominator? In the denominator, how many more is the 5 versus 3? 2. So when you divide, you subtract the exponent. So x to the 3rd goes into x to the 5th, leaving x squared down below. 5 minus 3 is 2. And now you handle the y's. Y to the 7th over y to the 4th. Whichever exponent is bigger, that's where y will end up. The numerator has a bigger power. How many more is 7 versus 4? So y to the fourth goes into y to the seventh, leaving a y to the third in numerator. Everything that can reduce has been reduced. Now, real quick, going back to the 81 over 144. No, I didn't mean to just pull the 9 times 9, 9 times 16 right out of the hat or something. 81 over 144. If you didn't see the 9, let's break this down. What would be your first inclination for what makes 81? 9 times 9 possible. And then 144, we just came from 12 squared. So I might go back to 12 times 12. So I don't see anything. So there must not be. What about 9 and 12? Do they have anything common? 3s. So you can't quit until you exhaust all the possibilities. When we have 9, we have 3 times a 3 times a 3 times a 3. This one is a couple of 3s, and that one's a couple of 3s. And then this is a 3 times a 4, and that one's a 3 times a 4. And that's where we get 3 over 3, 3 over 3. 3 times 3, 9, 4 times 4, 16. One other way to think about it. You get to use a calculator for anything at any time. Not a phone, not a tablet, not a computer, but you can use an actual calculator for anything at any time. You knew you were going to probably use 9 times 9. Then maybe on your calculator, you see, okay, this 9 going to 144. Oh yeah, 9 goes into 144. 33, no. Yeah, 48 times. No, 16 times. 16 times. So then you can go to this. 9 times 9, 9 times 16. Because you're going to choose 9 times 9 anyway, then check to see, does 9 work here? And all you do is just check on the calculator, does 9 go into that? But in math, we do not guess. We don't just stare. Staring isn't going to get it done. A piece of paper and a pencil with a good eraser, that's how you get these things done. Okay. All right. If it's from the first quiz prep, second quiz prep, third quiz prep, tell me which number, tell me which problem. I'll tell you right now, your quiz is 4 problems and 2 bonus. So only 4 questions and 2 bonuses. A lot of them we've already done, that's fine. The bonuses are more like the last few questions on each quiz prep. Quiz practice. I'm trying to rewrite these with the same title, this preps. Shy. On the new one? Oh, okay, number 6 on the first. Okay. That is. Quiz prep number 1, this is 6. Negative 12 times 5, x to the negative 4, y to the 5th, and then parentheses, that's the second, times 10, is in the parentheses, x to the 7th, y to the negative 4, the whole thing to the negative 2. First thing, this negative 12 is not raised to anything. This negative 12 is in the numerator no matter what. Everything in here is going to get squared. I'm going to write that out, but I'm going to keep the parentheses. It's negative 12. And then I've got a parentheses. And inside the parentheses, 5 is going to get squared. So 5 to the second. Actually, I'm just going to write 5 to the second. Then I have x to the negative 4. And that's going to get raised to the second. That second. And then I have that y to the 5th. And that's going to get raised to the second. So that's this first parenthesis. And then the next parentheses, I have everything here is going to get raised to the negative 2. So I have that 10 to that negative 2. And I have this x to the 7th. And it's going to get raised to that negative 2. Then I have that y to the negative 4. And it's going to get raised to the negative 2. I'm going to start flipping yet. I'm going to simplify. I've got powers to powers. I have a negative close still here on the outside. Write it down. One thing I'm going to make sure I point out. As you do the problem, hear the voice in your head. Either you're mumbling it to yourself. Okay? And as you do the work, you're not going to want to just work on this piece and keep on going down because you're going to forget to bring something over here. Keep working the whole thing from left to right. And then come back and do the next step here. If you want partial credit, if you want to maximize your points on any problem, you got to be organized and neat about it. It's not about what you understand or what I can read it. Remember, I'm the one that's going to be able to read it. I'm trying to model what I hope you're gonna do. Okay, I'm not gonna give up on you. I'm gonna keep on doing it this way. But if I can't read what you're writing, I can't see your work. Remember this right here, you might have the right answer, but if you get this, the right answer, but you see this, work does not justify your answer. I can't tell how you got to that answer. The work doesn't make any sense to me. So I don't know where you got your answer. So from here, we got the -12. Inside, 5 to the second is 25. This is a power to a power. So we multiply -4 times 2, that's an x to a -8. Power to a power, 5 times 2, that's y to the +10. Over here, I'm not going to do this because it's a negative power. I'm leaving it alone. I'm not going to flip anything yet. Small bind, so it's 10 to the -2 still. Power to a power, 7 times -2, so that's x to the -14. And then we have y power to a power, -4 times -2, that's y to the +8. Now, I'm going to do some flipping. If there's a negative exponent, it flips down. Does -12 flip? No, we don't flip negative numbers. We only flip negative exponents. So in the numerator, it's still -12. Does 25 flip? No, it's a positive 25. X to the -8, it has a negative exponent, so it's going to flip down and it becomes x to the +8. What about y to the 10th? Does it flip? No, it stays up. It's a +10. So in this parentheses, the only thing that flipped down was that x to the -8. In this parentheses, what about this x or the 10 to the -2? That'll go down, so I'll get 10 to the -2 down, or +2 down here. Because when it flips, it becomes a positive exponent. What about that x to the -14? It flips down, becomes x to the +14. What about the y to the 8? It stays up there. And I have down here y, or up here y to the. Remember what I told you. Let's not multiply -12 times 25 because you're going to have to reduce it. Maybe 25 or maybe the 12 is a common factor of the denominator. Let's see. So take your time. Let's see what we end up with. In the numerator, we got a -12. We have times 25. We have y to the 10th. We have a y to the 8th. I'm just kind of cleaning things up a little bit. Down here, 10 squared is what? We have 100. We have an x to the 8th and an x to the 14th. I'm going to simplify that in a second. But that's kind of just cleaning up what it is. You don't have to show this definition. If I go right to the next step, people are going to go, well, how do you get that? Does either one of these reduce nicely with 100 right now? 25 and the 100. The 100 is 4 times the 25. So I can reduce the 25 over the 25. But make sure you write down what you have left. A negative over a positive. It's going to be a negative. I have 12 over 4. What's y to the 10 times y to the 8? Yeah, that's right. Y. So what did I do with those exponents? You add. When you multiply, A to the M times A to the N, you add the powers. Okay? So the first rule of the exponent. The only time you multiply powers is when you have power to a power. So when we multiply, we add those powers. 10 plus 8, that's y to the 18th. 8 plus 14, this is x to the 22nd. And if you picture it, if I expand it, if I wrote it all out, I'd have 10 y's and then 8 y's. I would have y times itself 18 times. Okay, I wouldn't have 80 y's. I'd have 10 of them times 8 of them, so I have 18 y's almost plus. Is there anything left that I can read? 12 and 4. So 4 goes into 12 how many times? 3. Now, is it 3 in the numerator or denominator? Is it up or down? Up. This is up here, 4 times 3. And down here, 4. 4 goes into 4 once. That reduces. Negative 3 y to the 18th. All over x to the 27th. Now, where could you have made it quicker? You could definitely go from here to here. And you probably could go from here to here. You don't have to. Remember, the goal is to get them right, not to finish first. I'll do another one if it's quick. Yeah.
Quiz number 3, number 7.
We don't see number 7. Do not have picked a quicker question. Like all those other things out. If you assess everything, you remember way back when, who knows, maybe it's high school, maybe it's another class, where it says read all of the directions, make sure you read the whole problem before you actually start the problem. If you know your rules of exponents, like number 7, the 0 exponent, anything and everything to the 0 power equals 1, as long as it's not 0 to the 0. So if you look at this entire question, yeah, you got a whole lot of cleaning up to do, but no matter what you do, when you finish cleaning all of this up, it's to the 0. So why do all that work? Okay. It's fine, the final inner part of the denominator or the base is going to be a whatever, but the final step would be raise it to the 0. So that would just be it becomes 1. So when you read the entire question, oh yeah. And how are you supposed to know? I've seen an example like it before. Look out for this thing. I wouldn't want to see any other work. Come on back again. If you got here late, make sure you see me so I don't mark you absent.